2025 papers of May, June. So we're going to look at really which are the main topics really you need to prepare as far as that particular exam is concerned, because you are remaining exactly with 1 month for you to, less than 1 month for you to sit for that exam. What are the main areas you need to prepare for you to sit for that Cambridge paper 4 of 2025 May, June? So something that you need to understand is that this paper is usually about 80 marks, and is a theory and structured question that you are going to do, whereby you really need to understand the concept, and maybe then you are expected to apply the concept. So you need to show your steps. It will involve calculations, it will involve description, and at the same time it will really involve how you are going to approach that. So the main concept that I really feel that are very important, you need to understand motion graphs, on how you can be able to describe motion of graphs, calculations involved from those graphs. You need to understand the concept of energy transfer and energy resources. You need to understand concept to do with impulse, momentum, collisions, and also combining forces. So these are the key concepts that are very important. Pressure is really very key for you to go through that and ensure that all this you are going to so more of concepts that are quite also important. I've seen last year, of course, they asked about Hooke's law. The exam of web match, Hooke's law was asked, and I think this is a concept most of the students really find a bit difficult to understand. So you need to understand how to state Hooke's law, how to use the graph in order to state the spring constant, to determine the spring constant. And also you need to understand, sometimes you'll be given on the y-axis, you may be given extension, or you may be given load here, or you may be given length of the spring or the material that is being stretched. So whenever the question is asked, you need to understand how you can be able to approach it. So you're going to check in the description below here. You'll be able to see this particular kind of model answers I'm going to work out. So I believe you're going to work through this paper so that you can be able to answer the questions in the exam. So another concept that is quite important is thermophysics. Under thermophysics, you are going to talk about energy transfers. You're going to talk about specific heat capacity and how you can be able to calculate energy absorbed or energy released from ice. Okay. We talk about, of course, I've mentioned about energy transfers and energy resources. Yes. Another concept that is key is the concept of, still this is energy transfers. We continue moving down. We'll talk about waves. You'll talk about refraction. We talk about lenses. We talk about optical fibers, and also the concept of what? The concept of critical angles and total internal reflection. So basically, those are the main keys that this is, of course, diffraction, which you really need to know. Charges, you need to understand that. Electricity, we have questions on that. Then we have question to do with electromagnetic induction, also a concept that you really need to understand how to work out. We shall talk about potential dividers, which we shall be able to discuss in the next tutorials. So you can also check on transformers, step-up transformers and the step-down transformers. You need to understand about radioactivity, and then how you can be able to use such kind of graphs in order to work out half-lives. And then finally, we shall talk about space physics. So those are the key areas, the main concept that you need to know as far as the May June exams concerned. So if you have not subscribed to Profland YouTube channel, subscribe so that anytime I'm going to upload the walkthrough of this particular paper I've just shared here, you'll be notified. See you in the next video. If you are new to Profland YouTube channel, consider subscribing so that when I'm going to upload more tutorials for more other subjects, you'll be notified. So let's go straight and look at which is the other section that we were supposed to talk about. And here I need to mention that we had talked about electromagnetic induction, we had talked about electricity questions, we had talked about how to solve a question to do with transformers, how transformer works. So if you have not watched that part, indeed you really missed a lot. Make sure you check in the link that I've added in this particular video down there so that you can be able to get started. Question like this to do with potential dividers, we really discussed on how to work out. That was done in part 3. So let's go straight and try to figure out how to work out question to do with radioactivity. Here we are told that carbon 14, remember the number at the top is the mass number or the nucleon number, and the number below here, like 6 here, is representing the proton number or the atomic number, which is the number of protons. We are told that carbon 14 is a radioactive isotope. You need to understand, what do we mean by the term isotope? Isotopes are atoms of the same element which have the same atomic number or same number of protons, but different number of neutrons. Explain how atom of carbon 14 differs from the atom of carbon 12. We need to understand that they have the same proton number, but they have different number of neutrons. So you can say carbon 14 has 2 more neutrons than carbon 12. So atom of carbon 14 has 2 more neutrons, and so that means it's going to be more heavier than the other one. Describe how the amount of carbon 14 in the dead organism decreases with time. We were told the half-life is 5,700 years. So meaning after every 5,700 years, the remaining carbon 14 atom decreases by a half. So what's half-life? If you are asked what's half-life, what are you going to say? Half-life is the time taken for the activity of a radioactive substance to decrease by a half. And in a short while, we are going also to look at how do you find half-life from the graph, because those are the possible questions that you may be asked. So for radioactivity, you need to understand that. And we're told that the sum of wood, remember initially it was having a ratio of 1:1. So carbon 14 and carbon 12 were in a ratio of 1:1. After some years, the ratio becomes 1:4. So meaning it has decreased by reduced carbon, has reduced by a quarter. So how many half-lives has it undergone? After one half-life, it becomes a half the original. After another half-life, the half now become half, which becomes for a quarter. So which means that we have this a quarter is corresponding to 2 half-lives. And we know one half-life is 5,700 years. So which means that the total duration since the decay began is going to be 2 times 5,700 years. And that becomes 11,400 years ago. Explain why the short half-life is suitable for this use. Radioactive substances or isotopes are used for different purposes. To determine the age of a plant, carbon is used. To determine and to diagnosis, for treatment of some ailment, we have what we call radioactive tracers. Radioactive tracers have to be they must have a short half-life. So if they have a short half-life, it means that they can disappear from the body. If they have a short half-life, they can disappear, or their effect can decrease within a short period of time from the body. So when they have a small half-life, a short half-life, then they can be used as stressors in medicine. And then they have a short half-life, so they don't stay in the body for long. If you're given carbon-14, then you are supposed to draw the model of that. So remember, neutrons are usually inside the nucleus and protons, and the electrons are orbiting around. So you shall have the neutrons and the protons inside the nucleus, and then we shall have the 6 electrons around. And remember, the number of electrons is equal to the number of protons. Moving further, describe how the composition of a neutral atom of carbon-14 differ from the composition of neutral of nitrogen-14. And nitrogen-14 has one more proton than carbon-14, even though they are having the same nucleon number in that case. Carbon-14 decays by beta emission. We are supposed to state what does beta emission represent. These are fast-moving electrons. Describe the change that takes place when carbon-14 emits a beta particle. We know that beta is an electron. Yes, it has a mass number of 0 and proton number of -1. So meaning the neutron number inside the nucleus is going to be transformed into a proton and an electron. So describe the change that takes place carbon-14 as the beta particle is emitted. So the neutron is transformed into a proton. Half-life of carbon-14 is 5,700 years. A very old object is made of wood containing 1.2 atoms of carbon-14. When manufactured, it contained 9.6 times 10 to the power 11 atoms. But now it has 1.2. So we are supposed to determine when was it manufactured. So it means that we need to go to the original, which is 9.6 times 10 to the power 11. We decrease by 1/2, it becomes 4.8. Decrease that by 1/2, it becomes 2.4. Decrease that by 1/2, it becomes 1.2. So we start counting how many half-lives have taken place since it was manufactured until the current radiation that we are being, the current atoms that we are having. So we have 3 half-lives. So we take 5700 times 3, and that becomes 17,100 years. So that is how you can be able to use half-life to determine when a quantity was manufactured. We are told only one isotope of gold occur naturally on Earth, and then state what this indicates about the nuclear structure of all naturally occurring atom of gold on Earth. This indicates that all atoms have the same protons and the same neutrons. If they were having different, it would mean that they are going to exist in different isotopes. So determine the number of protons. So how do we approach that? We're told there are several artificial produced isotopes of gold. Gold 198 is an artificial isotope. It's used in medicine, in scientific research. Gold 198 decays by giving beta emission to a stable isotope of mercury. Determine the number of protons, number of neutrons in the nucleus of isotope of mercury. So in this case here, it was gold. Now it has become mercury. So what is the transformation? It was 198. It has to remain 198 because the mass number of an electron is 0. But 79, this has to be 80, so that 80 plus -1 becomes 79. So the number of protons in this case is 80, and the number of neutrons remains to be, number of neutrons is 118. How do you get that? You take 198 minus the number of protons so that you can be able to get the number of neutrons, because atomic number is equal to the number of protons, which is represented by the number on the subscript. Neutron number, nucleon number, or mass number is protons plus neutrons. So I believe you will remember that during your exam. A sample of gold 198 is placed near a radiation detector in a research laboratory. The rate is recorded at the same time every 32 days. The results are used to plot a graph here. You are supposed to determine the background radiation. Background radiation, you are supposed to check where it flattens. You read the value here, which is 20 becquerel counts, yeah, the count rate per minute. Remember also the unit for radioactive decay is in becquerel. So maybe if you are asked that, you'll be able to answer that. Determine the half-life of gold 198. So first, you need to come and check what's reading here. The reading here is 390. Then we have to correct that count by subtracting the background radiation or the background count. So we subtract that, and then now half-life will be that corrected count divided by 2. Then you come and check where do we have 185. 185 is at this point. Then you will read the value down here, which is approximately 3.2 days. 3.2 days. So in the event you are supposed to answer a question to do with radioactivity, this is how you approach some of the question. Let me also mention a possible question that can be asked here. You can be also be told to, let me just return this mic so that we can be able to continue. You can also be asked to state sources of background radiation. Sources of background radiation include cosmic rays from space, rocks and buildings, and also we can talk of plants because they contain carbon, right? Argon, radon, and argon gas also can contribute. Now let's move to space physics. Under space physics, we are told that a Milky Way is one of many billion of galaxies. A collection of billion of galaxies forms what? Milky Way is one of the many billion of galaxies we have, and each galaxy contains billions of stars. A collection of stars is called a galaxy, right? And stable stars transfer energy into space by emitting electromagnetic radiation from their surface. Describe what happens to the core of a stable star to release energy. In the core of a stable star, hydrogen nuclei fuse. Fusion reactions are the one that result to the production of energy for stars. Yeah, so in a stable star, there is fusion of hydrogen and hydrogen that leads to the formation of helium. So the fusion process is the one that results to the production of energy from stars. That's what you need to know. Also, describe how the light observed from the galaxy differ from the light that is emitted. Remember, the galaxy is moving away, so the observed wavelength is larger or longer than the emitted one because of the redshift. So you need to understand that also. State the code that astronomers use to determine the speed of a galaxy. That's the change in wavelength. And also you need to understand Hubble's law. And Hubble's formula is given here. H is equals to the speed of a galaxy divided by the time, rather divided by the distance between the astronomer and the galaxy. And if we work it out, we are going to get the distance being 5.9 times 10 raised to the power 24 meters. So you need to understand Hubble's constant is 2.2 times 10 raised to the power 18. And using this, we can also determine the age of the universe. I believe you may be asked questions from calculating the age of the universe. Anytime you are asked a question like that, remember age of the universe is 1 over Hubble's constant, which is 1 over 2.2 times 10 raised to the power negative 18. If you work it out, you're going to get 4.5 times 10 raised to the power 17 seconds. but here we are supposed to work out the age of the universe in years. So you are going to say this time in seconds divided by 3.3 times 365 days times 24 hours times 3,600. So anytime you're going to be asked question from space physics, you remember that. Something I need also to mention that you may be asked as far as the May June exam is concerned is the concept of orbit of comets, orbit of planets, and orbit of satellites, i.e. the moon. You need to understand the differences. The difference of the orbit of a comet and that of a planet is that the orbit of a comet is elongated, very much stretched, right? But the orbit of a comet is of course elliptical, but for that of a planet is elliptical, yes, but that of a comet is quite elongated, quite stretched. And if you have a challenge answering space physics question, I've added a link of the video I prepared of possible questions that can be tested. I picked many questions from past papers and I put them together as one video for space physics, where in that video I've discussed how you can be able to calculate orbital speed, how you can be able to answer questions to do with phases of the moon, different aspects of space physics. Can you check the link in the description so that you can be able to watch that video, and also you can be able to download the PDF of that answers that I wrote there. So just check below. And if you're new to Proflan YouTube channel, consider subscribing so that when I'm going to upload more tutorials, you'll be notified. See you in the next tutorial. All the best in your coming exam, May June. We shall also be testing possible practicals, questions that will be asked in this coming May June Cambridge Physics. See you in the next video. Leave a comment and also subscribe to share this video to your friends so that they can be able also to benefit. So let's dive in so that we can be able to get started on how you are supposed to answer this question. And we need to see now what was the main question that was asked. What were the questions that you are supposed to focus on? The first question that we said here is the question to do with motion graphs. And something that you need to be very careful with is understanding different features which is represented by motion graphs. For instance, if we are talking about distance time graphs, it means that the gradient of a distance time graph is going to give you velocity. But a graph like this one that we have here, which is a distance time graph, this graph is a speed time graph, which means the gradient of a speed time graph will enable you to get the acceleration of the object. And also you need to understand that another feature on a speed time graph that represent distance is the area under the graph. So I've seen questions like that, and at the same time you need to understand how you can be able to describe different motion graphs. Now, looking at this question here, we are told that a ship sails in a straight line between two ports, and then we are supposed to determine the maximum acceleration during the 100 minutes of the ship journey, right? So if you look at the gradient of each of the line, you see if I draw a tangent at this point, we're going to have a slanting line. As this line, if the line is steep, it means a high gradient. If the line is not very much steep, it means a low gradient, which also communicates less acceleration. So acceleration at this point is going to be less than this, and acceleration is highest where we have this particular section. That's where we have a very steep gradient. So what I did, I obtained the gradient of this section, and rise is 5 and the run is 12. But you have to remember that time was given in what? In minutes. And the speed was given in what? In seconds. So whenever you're going to work out the acceleration for the run here, I have to convert the 12 minutes to seconds by multiply by 60. And when I worked out, I got my acceleration translating to 6.9 times 10 raised to the power -3 meters per second square. And we were supposed to calculate the total distance. And I mentioned that from a velocity time graph or this speed time graph, if you work out the area under the graph, it means that is particularly the area under the graph represents the distance covered. So don't use the formula that distance is speed times time in this part. If you are given a graph, remember area under that section is represented by the area under that section represents the distance covered. So if we are talking about 42, remember we are told to consider 42 seconds all the way to 100 seconds. So which means we are going to work out the area of this section here. I subdivided it so that I work out the area of this trapezium, and then I work out the area of this rectangle in this particular section, so that I add the two areas together. Plus, now we work out the area of these rectangles, that rectangle that we have here. So that's going to be 60 to 100, that is actually 40. And then the height is 15, so that is going to be translating to what? So 40 times 60 times 60. This is going to be 2400 times 15. So if we work it out, I have to eliminate this one from here. So if I work out the total distance traveled, this is going to be 0.5 times 1080 into brackets 8.5 plus 15. So the bracket, then plus bracket 200 times 15, and the total answer becomes 48,690. So the total distance becomes 48,690 meters. So, and in the event you are asked to convert meters to kilometers, you need to divide by 1,000, and that becomes 48.69 kilometers, which is the same as 48.69 kilometers. So this question did not really specify in which unit you are to give, so you can decide and give it as 48.69 kilometers, right? So the take from this particular tutorial is that ensure when you are working out acceleration from a speed time graph, you work out the gradient, and when you are working out distance covered by the object in a given section of a graph, you work out the area under the graph, right? So we need to move to the next part, whereby we are supposed to calculate the resultant force that acted on the ship, whereby there is an acceleration of 0.0087, and we are given the mass. We are going to use the relation force is equal to mass times acceleration, and then if you apply that, you are going to get your answers 2 times 10 to the power 5 Newton. That's the force. That's according to Newton's second law of motion. That's when a force is applied on an object is going to accelerate. And if you take the mass of the object times the acceleration, you get the force that acted on that particular object. We're supposed to explain why the force of the ship due to the ship's engine is greater than the value calculated. So something that we need to realize that some of the forces exerted from the ship's engine is used to overcome air resistance and also water resistance as the ship is moving through the ocean. All right, so moving to question number 2, and in question number 2 we are talking about energy resources, and we are supposed to say the form of energy stored in water when electrical energy, hydroelectric power is being generated. And remember, most of the time what happens is that water is trapped in a dam on a raised area. Then that water is released so that it can be able to pass through the turbines, and it rotates the turbines so that it generates electricity. So the energy that is being used there is gravitational potential energy, which is converted to kinetic energy, and then it rotates the turbines, and then the turbines are able to rotate the shaft of the generator in order to produce electricity through electromagnetic induction. So we are going to look at the rate at which energy is transferred. Remember, the energy that we're talking about here is the energy gravitational potential energy. So, and gravitational potential energy is calculated by the formula energy equals to mgh. So, which means that we are going to substitute the value that we have into the formula so that we can be able to get that energy. But remember, the water is being released at 480 kilogram per second. So our rate is also going to be energy over time. Then if you work out the potential energy, you are going to get your answer here. Then our energy is 1.9 times 10 to the power 6 joules per second, remember. And then we are going to divide by time, which is 1 second. And then the rate becomes this. And something that we need to remember is that rate at which energy is transferred is basically power. So this is also referred to power. Now, the power scheme supplies a current. So this is the output power we can talk about in Roman 2, because we're given the current as 270 amperes and we're given the voltage as 600 volts. Yeah. So which means from electrical power, we know that power is equal to current times voltage. So which means that if we multiply 270 times 6,000, it means we're going to get 1.6 times 10 to the power 6 watts. And efficiency is given by the formula that power output is over total power input times 100. We get what? We get the efficiency. So if we plug in those values into that, we are going to get the power being translated to 84.2. Yeah, 84.2 percent. Yeah, and you are supposed to know in this topic advantages and disadvantages of hydropower schemes. The first thing that we need to realize here, the advantage is that they can produce enough energy and can meet the demand of the power that is required. They produce enough energy, of course, but the shortcoming is the initial capital that you need to start a power plant is really very high. And we can talk of the ecosystem being destroyed, because for you to create that dam, you need to restructure the landscape. You need to destroy the habitat of wild animals. You need to displace people. So you need a large space. And also during dry seasons, you cannot have enough water to run this. So those are some of the disadvantages that we can talk about. Now, you need also to understand the difference between renewable and non-renewable energy resources. Those energy resources that you cannot deplete, you can never finish them, even however much you can be able to use them, they are called non-renewable energy resources. And those resources that you will be able to deplete, you cannot use them forever. They can be depleted. They are called non-renewable energy resources. So my question is, what are the examples of renewable and non-renewable energy resources that you know? So at this given point, we shall talk about renewable. Solar, will you ever use the energy of the sun and finish it? You can never deplete it. Will you ever finish the energy of wind, waves and tides? Geothermal, you will never deplete that. So those are some of the examples, but you need to revise more on that so that you, whenever a question is coming from there, you'll be in a position to answer that. So you need to understand also the concept of impulse and the concept of momentum and Newton's second and third law of motion. So first we need to appreciate the fact that impulse is the product of force and time. And impulse is equal to the change of what? The change of momentum, all right? All right, so in this case, we are supposed to calculate the resultant impulse on the balloon while it's accelerating. So we are having this balloon that is at this given point, whereby the moment the air is going to be expelled from the balloon, this balloon is going to what? To move forward. Because as the air is being expelled from the balloon, there is a change in momentum. There is a force exerted on the balloon, and the balloon exerted force on the air as it's being excited. So the balloon is going to accelerate what? It's going to accelerate forward. Now, we are told as the air leaves the balloon, it experiences a force. The balloon accelerates from rest until it reaches a constant speed. It then travels from 0.67 meters in how many seconds? 0.18 seconds, as this constant speed. Now we are supposed to calculate the resultant impulse. Now the first thing that we are going to do here is to use the formula V is equal to distance over time in order to get the speed, the constant speed attained by the balloon. Now once we have attained that, we are going now to go ahead and then use the formula impulse is equal to change in momentum. And we have our formula at this given point, whereby we are going to say change in momentum is equal to mass into bracket final velocity minus initial velocity. Remember, it was at rest, right? So if it was at rest, the initial velocity was 0. So which means that if we apply the formula, we're going to get 0.555 kilogram meter per second. That is the formula, the units for impulse. And also impulse can be given in Newton seconds. So you can give impulse units as kilogram meter per second, or you can be able to give them as 0.55 less. The law of conservation of momentum states that momentum before collision is equal to momentum after collision, provided there is no external force acting on the system. Now we are supposed to explain how momentum is conserved when this balloon accelerates. So as air is being expelled from the balloon, we know that it will accelerate forward because the speed, we were told that the speed is decreased, so it accelerated. And the air gained, so which means that as the air gains momentum in one direction, the balloon also gains equal momentum in the opposite direction. So you see momentum is a vector quantity, right? So if there's momentum acting in this direction and momentum acting in the other direction, then the two momentum will cancel out. So the balloon gets momentum in one direction, and the air also gains momentum in the opposite direction, but of equal magnitude. So we can be able to see that now momentum is the same, momentum is conserved in that particular case. Another concept that is key and important for you to remember is how to combine different forces that are acting on the body. And then what I did, basically, I moved this force in front here so that I could be able to work out the resultant force. And the resultant force, when we are having forces which are perpendicular, we're going to use Pythagoras theorem so that we can be able to say now the resultant force R is 0.4 squared plus 0.74 squared. Finding the square root of that, we are going to get our answer as 0.84 newtons. But since we're told to find the direction, and force, remember, is the vector quantity. Something that you need to remember is that vector quantities have both size and direction, and scalar quantities only have magnitude or size but no direction. So we are talking of a force. Force has both size and direction. So we need to find the direction relative to the horizontal. So if relative to the horizontal, then we are going to work out the angle that we are having here, which is going to be tan inverse of 0.74 over 0.4. That translates to 0.84 newtons as the magnitude, and the angle becomes 62 degrees. Moving to still talking about pressure, we shall talk about how pressure, our temperature affects pressure, and in this case, we are being told, explain in terms of particles how the air pressure inside the bottle changes as temperature increases. So something that you need to realize is that as temperature increases, the kinetic energy of the particles increases. So this results to a more frequent collision per unit area. So when the temperature increases, the kinetic energy of the particles increases, and this increases the frequency at which the air molecules or air particles is going to collide with the walls of this container, and this results to increase in pressure. So basically, this is the model answers you are supposed to write in your exam so that you can be able to earn all the formats. And if you have not subscribed to Prof Learn YouTube channel, consider subscribing so that in time I'm going to upload the second and third section of this tutorial will be notified. So let's move down. We're supposed to explain that we are told that the lid is removed from the bottle. State and explain how the air pressure changes. So if the lid is removed, it means that some of the air particles and molecules going to exit. It's going to escape from the container. So we are going to have fewer particles inside the container. So there will be fewer collisions on the walls of the bottle. Then this is going to result to a decrease in pressure. The mass of water in the bottle is 0.18 kg, the specific capacity of water. Now you can see they are bringing the concept of thermophysics inside this. Quite interesting. So under thermophysics, we are learning about how to calculate thermal energy. And thermal energy equals mass times specific capacity times temperature change. So in this particular question, we're given the mass. In this particular question, we're given the specific heat capacity, which is given here, right? Interesting. And then we're given the temperature change, which is going to be our beautiful data at this given point. So this is the formula we're going to apply at this point. Now, once we have that, and you substitute between, we are going to get the answer being equivalent to 15,120 joules of thermal energy. Yes. As if that is not enough, they told that you never attended the class of pressure in fluids. And then they are going to ask pressure in liquids, which is going to be pressure in liquids is height times density times gravity, H log G. We are told another bottle is filled with the water to the top, and the bottle is 40 centimeters. 40 centimeters. You need to be very careful with that because they are not giving you the height in meters, so you have to convert it. Yeah. So if you forget that, you will start crying about the great boundaries. All right, so we are going to say it's 40 over 100 for us to convert the centimeters to meters, times the density, which is 1.0 times 10 to the power 3, times 9.8, which is gravity. And the gravity is just provided at the first page of your paper. And if you work it out, you're going to get 3920 pascals at the unit of pressure. All right, so moving down to question number 5, let's see the kind of question that was asked. Again, is a question from pressure, but it's a different concept, which means smelling from, the question is smelling like it's coming from pressure, but different questions are being approached there. And then the question said here, we have a balloon, yeah, which is inflated with air, so meaning we're having air particles which are dancing there, according to kinetic theory of matter, that states that air particles are in a continuous random motion. If we are talking about particles in this particular balloon, this particle will be moving in a random zigzag manner, colliding the walls of the container. As temperature increases, the kinetic energy increases, the number of collisions increases. So as the air moves around, it collides with the walls of the balloon, and this results in the change in momentum. And when there is a change in momentum, according to Newton's second law, there is a force that is going to be exerted. And the force exerted per unit area is actually pressure. So in the event that you are told also that the volume of air in the balloon is 630 and the pressure in air is 1.0 times 10 raised to the power 5 pascals, and the balloon is tied to a heavy stone and then dropped into a lake, pulled down to the floor, then the pressure at that point is 1.4 times 10 raised to the power 5 pascals. We are supposed to calculate the volume of the air when the pressure is that. So we are going to use the formula pressure P1 times V1, pressure 1 times volume 1 is equal to pressure 2 times volume 2. So meaning that this is our V1, this is our P1 here. And then we are having P2 at this point. We are looking for what? Volume 2. Now substituting that, we are going to get our answer being equivalent to 450 centimeter cubic. We see then from here, as pressure increases, volume decreases. So which means that if we are talking about pressure and volume, pressure is inversely proportional to volume. Sometimes you will be told to sketch that graph, that as pressure increases, volume decreases. Explain why the volume of the air in the balloon decreases. We have already said that pressure is inversely proportional to what? Volume. So as pressure increases, volume is going to do what? Volume is going to decrease. So which means as temperature increases, the kinetic energy of the air molecules decreases. This decreases the number of collisions in the volume. So that decreases the pressure. Hence, there is less force exerted on the balloon, so it will do what? It will compress. But the key fact here is that pressure is inversely proportional to volume. Okay. Yeah, so that is just added information and just putting on here. Let's look at the next question. And the next concept that I need to mention here is the concept of Hooke's law. You need to understand how to define Hooke's law. You need to know how to define Hooke's law. Hooke's law states that extension is directly proportional to the force applied, provided elastic limit is not exceeded. And the way you can be able to understand this also is that we have a limit of proportionality, yeah, at this particular point. The point where the graph stops being straight, that's called the limit of proportionality. Up to that point, extension is proportional to the force applied or the load, up to the last limit, the limit of proportionality rather. So if you are asked to define limit of proportionality, what are you going to say? If you are asked to define limit of proportionality, what are you going to say? Can you put it in the comment section there? What is the limit of proportionality? Just put it in the comment section. If you are preparing for these major exams, you should be knowing how to define limit of proportionality. From the graph, the limit of proportionality is the point where the straight line or the graph stops being straight. That point where I've indicated. And then you need to know how to state. So if you are asked to state limit of proportionality, you define it. we're going to say this is the point up, the maximum point up to which extension is directly proportional to the load or to the force. Maximum point up to which the extension is proportional to the load. Okay, all right. So if you have understood that, you need to understand also the concept of Hooke's law. Hooke's law formula is force is equal to the spring constant times this is times extension. So if you're working out the spring constant, you need the force and extension. So where are you going to get the extension and the force from? You go to the section of the graph where you have a straight part, then you can read the extension being 100 millimeters, and you read the force down here, or the load, which is 14 Newton. If you work it out, you are going to get your answer 0.14 Newton per millimeter. Right. And then there is another question you can be asked. The original length of the spring was 120 millimeters. The original length was 120, meaning when when there's no load exerted on that spring, it's 120 millimeters. Then calculate the length of the spring when the load of 8.5 Newton is added on it. So what does that mean? What does that mean? When a load is added on this, it's going to stretch. It is going to be long. So which means we are going to go to our graph. So once we go to our graph, we are going to check where we have 8.5 newtons, and then we read what is the extension when we have a load of 8.5. When I did that, I got it to be what? 60 millimeters. So for you to get the new length, it will be the original length plus the extension. Extension is by how much it has extended. So it has stretched. How much the length has increased. So which means that we are going to add 120 plus 60. We are going to get 180 millimeters. Now, another concept that you need to know at IGCSE level is how to calculate weight. Remember, weight is a force, so which is calculated by mass times gravitational field strength. So here, if we are told that the object was having a weight of 4.0 newtons, and the acceleration due to gravity of that particular planet is 8.7, then we have no option other than saying that mass is equal to weight divided by gravity, and that is going to give us 4.0 divided by 8.7, giving us what? 0.46. So weight is considered as a vector quantity because it has both sides and what? Direction. Yeah. And the difference between mass and weight is that mass is constant everywhere, but weight vary from one place to another because weights depend on gravity. Mass is a scalar quantity, weight is a vector quantity. So you need to know how to define different sections. So we are going to move to question number 7 in the next tutorial. If you have not subscribed to Prof Learn YouTube channel, consider subscribing so that when I'm going to do more of this section, you'll be notified. All the best. Good luck in your maiden exams. Leave a comment down below if this video was helpful to you. See you in the next video. Whereby we are supposed to move to the next part, whereby this part is what really is it really talking about? We were to move to the part where we are talking about the specific heat capacity, and then you are supposed to state what do we mean by the term specific heat capacity. So in that case, when you are asked during your May-June exams, you are going to say this is the amount of thermal energy required to increase the temperature of a substance by 1 degree Celsius. So you have to be very specific. That is the amount of thermal energy required to raise or increase the temperature of 1 kg of a substance by 1 degree Celsius. Then you are told here a question whereby you are supposed to use density to calculate the mass. we understand that density is equals to mass over volume. Yes. And then now the mass is calculated in kg here, but you need to remember that the density was given in kilograms and then the volume is given in centimeter cubic. So meaning we are going to divide by a million in order to convert the centimeter cubic to meter cubic, so that you can be able to multiply by the density for us to get the mass to be 0.5 kgs. So if you are new to Profland YouTube channel, consider subscribing so that whenever I'm going to upload the third portion of this tutorial, you'll be notified. So you need also to learn on how to work out the energy when you are given thermal energy, when you are given different parts. Of course, this concept here about latent heat of vaporization and latent heat of fusion is not really very clear to be done by 2025 students, but it is very good for you to know what is supposed to be done. In the event an examiner decides to test that concept, you know exactly what to do. So remember, thermal energy is given by the formula mass times specific heat capacity times the temperature change. So we are told that a bowl containing 500 centimeter cubic of water at a temperature of 5 degrees Celsius, the bowl is placed in a freezer. So meaning the temperature will decrease from 5 degrees Celsius to 0. So which amount of thermal energy will be given? It will be 0.5 times 4,200, which is the specific capacity of water, times the temperature change from 5 to 0. That amount of heat will be given out. Okay. It's very cold here. I'm just having a cup of coffee just to raise a little bit the thermal energy of the body. Yeah, it raises a little bit the thermal energy. So also we are told that when the bowl is removed, the temperature of the water or the ice, it becomes negative 18 degrees Celsius. So meaning the amount of thermal energy supplied for all the amount of water to be converted to ice is going to be 0.5 times the latent heat of fusion, which is going to be 0.5 times 3.3 times 10 raised to the power 5. Then plus, now when ice now is dropping its temperature from 0 all the way to negative 18, so the temperature change there will be 18. So we are going to use the mass of ice times the specific capacity of ice times 18. So if you work it out, you are going to get your answer equivalent to 194,400 joules of energy. Another concept that you really need to understand is about energy resources. You need to understand how to define renewable energy and non-renewable energy with their examples, advantages of renewable energy, disadvantages. You need to understand types of resources, of course, and then how to define them, and then different examples. So in this particular question 8, we are supposed to state 2 energy resources for which radiation from the sun is the main source. So this is solar energy. Solar energy, if you take solar panels, they will absorb the energy from the sun, and then it's used to warm and heat water. But wind energy, because the radiation or radiant heat from the sun hits the ground or the earth surface at different uniformity, and then it means that different regions of the earth are going to be at different temperatures. So regions where the sun hits most, or there is a lot of thermal energy, that air around there will become less dense, right? It will rise up. Then dense air will just move to replace the less dense air that has actually been risen. So meaning we are going to have now wind flowing. So another concept you need to understand also is about thermal, besides thermal energy, besides energy resources, you need also to know how to calculate kinetic energy. And we know kinetic energy is equal to a half mv, a half times the mass times the speed squared. And also you need to remember the concept of gravitational potential energy, which is also mgh. Yeah, GPE is equals to mgh. So in this case, we're told the wind turbine is used to generate electricity, and the useful output from the turbine in 1 second is 6,000 joules. The kinetic energy of the wind hitting the turbine in 1 second is 11,000 joules. Then we're supposed to calculate the velocity of the wind hitting the turbine is this. Show that the mass of air is approximately 550. So meaning you are going to use the formula kinetic energy equals to a half mv squared as stated here in the formula, and then you are going to substitute kinetic energy is 11,000. Then we are going to make m the subject of the formula in this case, so that we can be able to say our answer becomes 554, which is actually rounded down to 550 kgs. We're supposed to calculate efficiency. So another concept that will be very, very key in this coming May, June exams is the concept of efficiency. Do you know how to calculate efficiency? Of course, efficiency is useful power output over the total power input times 100. That's exactly what you're going to do at that particular point. Sometimes you'll be given about question to do with disadvantages and advantages, and that's basically what's forecast here. The tidal energy and wind energy are both renewable energy resources. Renewable energy resources are those energy resources that you can never finish. They can never be used up. They can never be depleted. But non-renewable, they can be finished up. Yeah. And also remember those that contribute to global warming. So you need to be very, very careful reviewing all the areas, so that when it comes to the main exams, you are able to reproduce their concept and apply that in paper 4, right? So suggest one reason why tidal energy is more useful than wind energy. Remember, wind energy is not reliable because it's quite unpredictable. You cannot be able to have a continuous flow of energy, because wind can sometimes flow at a very high speed, and if after a few seconds it disappears. So, but tides, they're kind of predictable. So you're going to base your answer on that. So another concept you need to understand is the concept of evaporation. How does evaporation cause cooling? And remember, evaporation takes place on the surface, while boiling takes place in the entire liquid. Evaporation takes place at any given temperature. Boiling takes place in a specific amount of at a specific temperature. So you need to understand the differences, and also you need to know how how evaporation enhances all causes cooling, because evaporation is a process by which energetic water molecules or liquid molecules escape from the surface. Those molecules which have high kinetic energy, they escape to the surrounding. The process, the net molecules, or the molecules left behind, they have less kinetic energy, so they have also less thermal energy. Then explain, as water is heated, the pressure of the gas inside the cooker increases. How does water molecules result to pressure? Remember, the water molecules, as you increase the temperature, kinetic energy increases, and this kinetic energy of the molecules enhances the collisions on the walls of the cooker. So this result from force exerted on the walls, and force per unit area is pressure. So that's why we are saying as temperature increases, kinetic energy kinetic of gas molecules increases, and the molecules collide more frequently with the walls of the cooker, exerting a greater pressure, exerting a greater force, and force per unit area is pressure, and that explains why. We are having a scenario here where we have a portable shower here. on a campsite and the bag is filled with water, and then that black bag is used to warm the water. Why is it painted black? This is the concept of this is the fact that black surfaces are good absorbers of radiant heat. So the choice of the black painting is due that black surfaces are good absorbers. So they are going to absorb more radiant heat from the sun, and they're going to warm the water. What is the disadvantage? Remember, this will only work when there is sun during the day, but at night when there is no sun, it cannot be able to work out. So this is not very reliable, right? Solar energy is a renewable energy resource. Which are the other examples? We have wind, we have geothermal, we have tides, yeah, and many others. So check on that as you are revising. During the day, the sun shines on the shower bag, and some of the energy in the infrared radiation from the sun transferred to the thermal energy store. And then we have, we are told only 60% of the incident is absorbed. Then the mass of water in the bag is 40 kg. The specific capacity of water is 4,200 joules per kg by degree Celsius. Then we're supposed to calculate the thermal energy incident to the shower. So first we were supposed to calculate the temperature change. That was 43. Temperature was 10 degrees Celsius. It increased to 43. So which means the temperature change here is at 3 degrees Celsius. But we know that thermal energy is MC change in data. So the mass is 40 times the specific capacity, 4,200 times 3. And that translates to 55. That is 5,554,000. Then now, since we were told that only 6% is absorbed, so since this is the amount of heat that is used to warm the water, so it means this is equivalent to 60%. 60%. So how do we work out the 100%? So we can be able to put that in, and we shall have the 9,240,000 joules of thermal energy that was applied, but only 60% of that was absorbed. So I believe that's okay up to that point. So the other concept that you really need to remember, to review, and to go through is the concept of refraction of light. Remember, refraction is the bending of light, or bending of a wave as it moves from one medium to another at the boundary. But diffraction is a spreading of a wave around a boundary all through a gap. So you need to understand that. And under diffraction, when the wave is moving through the gap, if the size of the gap is equivalent to the wavelength of that wave, is going to undergo maximum diffraction. So that will be very key. So with what we need to remember in this case, under refraction, in a dense medium, the wave is going to slow down. So speed is going to slow down when it enters into the glass block. But the wavelength also is going to become smaller, but the frequency is going to remain the same. So you need to remember also this wave equation. And of course, for you to work out the refractive index, you are going to use the formula N is equal to sine I over sine R. In this case, we have our sine I here and sine our refractive angle of refraction at this point. So it will be sine 45 divided by sine 30, so that we can be able to get our answers 1.4. Now, for you to work out the critical angle, to find the critical angle, remember the relation between the refractive index and the critical angle is that sine C is equals to 1 over the refractive index. And then if you work it out, you are going to get your answer being equivalent to 45 degrees. Yeah, moving down, you are supposed to state two uses of optical fibers. They are used in hospitals as endoscope. They are inserted into the mouth, through the mouth into the stomach, so that you can be able to see maybe the walls of the stomach in hospitals. But also they are used in communication, to pass information, to pass data. And the advantage to this, it can be able to carry a lot of data. And it also has very little resistance. Data is not lost in that process. So you need to understand that. And in the event they tell you to draw how light travels through it goes like that. To move this way, it undergoes total internal reflection. Yeah, at this point now, when that light reaches there, it's reflected at that point, and then eventually that light gets out like that. So that's basically what we shall talk about. So another concept under light waves you're going to learn is how to construct ray diagrams on lenses, and also the concept of explaining characteristics of the waves, the images formed by lenses. So for in this case, what you need to understand from the object here, this point, one ray will move parallel to the principal axis. That ray, the moment it reaches the lens, it will pass through the principal focus. And another ray will run straight from the object through the center of the lens and deviated like that. So you can see these two rays will never meet anywhere. They are diverging, diverging and diverging. So the only way we can have our image is by extrapolating the lines backwards, and the image is going to be formed at this given point. So this image has been formed by visual rays. This image cannot be formed on a screen, so it's called a visual image. But when you look at it, it's upright, it's magnified because the size is bigger. So those are the kind of characteristics that you are going to look at whenever maybe you are asked a question in an exam. So another way you can be asked here is a question to do with the distance. Maybe you can be asked to measure the distance. So you are going to put your ruler, then measure the distance, IY, the distance IY. Yeah. Okay, measure the distance IY along the principal axis to the center of the lens. So you'll measure this distance up to that particular point. So basically, you are going to use your ruler there in order to measure the distances. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials on this, you'll be notified. Also, I'll be doing more concepts in additional math, and also we shall talk about practicals, how to answer practical questions here. So we have every reason as to why you need to subscribe to Proflan. Also A-Levels, you'll be going for A-Levels, and Proflan would be a good place for you to be. Talking of dispersion of light, when light is incident to a prism, there is dispersion, separation of into different colors. So what we need to understand that blue light has a shorter wavelength, so it will diffract more. So if we have green light, it will follow that path, but blue light following the same path at this point, it will undergo a greater refraction. Yeah, it will bend more, and at this point also it will bend more. So for you to finish the way blue light will be able to travel, that's the way. But the concept is blue light has shorter wavelength, so it will refract more than green light. So the next part that we are talking about is charges, electrostatics. Remember, like charges repel and like charges attract. When a plastic rod is uncharged, when the rod is wrapped with woolen cloth, the rod becomes negatively charged. Explain in terms of particles why the rod becomes negatively charged. The rod becomes negatively charged due to friction. And this happens when electrons move from the cloth to the surface of the rod. So meaning, if we are talking of a piece of cloth like this, which is having positive and negative charges, and then when a rod is wrapped on this, the electrons will be transferred to the due to friction. So the piece of cloth is going to remain positively charged because electrons has been removed from it. We have a negative charged metal sphere and state what's meant by electric fields. In case they ask you such question, just respond by saying that this is the region where electric charge can experience a force charged near the sphere, a negative charge near the sphere. This will experience a repulsive force. So it will move away. It will move away at a very high speed. It will move away at a very, very high speed. Also state the concept of refraction. In this case, the examiner gave angle X. And remember, the angle X is between the oil and the incident. So angle of incidence is the angle between the incident ray and the normal. So that is the trick that you have to remember. So if you are given this angle, that is the trick. So you have to take 90 minus 56, you get 34, and that's the angle of what? Incidence. Then you are supposed to calculate the angle of refraction when the refractive index is 1.47. So to do that, you are going to say n is equal to sine I over sine R. Substituting that, we are going to get our angle equivalent to 22 degrees. And the approximate speed at which light moves in air is 3.0 times 10 raised to the power 8 meters per second. Don't forget that. Calculate the speed of light in oil. We are just basically here, the examiner is testing. Do you know that refractive index is also calculated by this formula? Speed of light in a vacuum over the speed of light in oil or any material. So that's what the examiner was testing. Basically, that's where I want us to stop in this particular tutorial. Next video, we're going to talk about electricity. Then we shall talk about electromagnetic induction. We shall talk about transformers and get to see how do you approach such kind of questions. So if you are new to Proflan YouTube channel and if you have not subscribed and you are going to sit for the May June exams, you have every reason to subscribe so that anytime I'm going to upload the next tutorial, you'll be notified. See you in the next video.